Hello students, this is Vijay Janadanushir. In the last lecture, we have studied about the adsorption of gases by solids. In that, we have studied the different factors affecting on the adsorption. So, the different factors affecting on the adsorption was the temperature, pressure, reversible nature, exothermic nature, specific nature, and the nature of the gas. And also, we have studied the adsorption of solutes by the solids. So, in this lecture, we will study the BET theory, that is bed isotherm, and in that we will study the determination of surface area of the adsorbent. Means in the bed, from the bed theory we will determine the surface area of adsorbent. So we will study the bed theory. So, bed theory aims to explain the physical adsorption of gas molecules on solid adsorbent. Means these BET means these are three scientists. This is Browner, Emmett and Taylor. So, the name for this theory is given from this scientist name, that is BET. So, this theory aims to explain the physical adsorption of gas molecules. So, physical, we have already studied there are two types of adsorption, physical adsorption and chemical adsorption. So, bed theory explains the physical adsorption of gas molecules on a solid adsorbent. And the theory of adsorption is proposed in 1938 by these three scientists, that is Stephen Browner, Paul Emmett and Edward Taylor. So this group of three scientists is known as a BET theory, that is a bed theory. And after the initials of these scientists, means the initials of these three scientists, that is BENT, the name is given as BET theory. And since the Langmuir theory, we have already studied the Freundlich adsorption and Langmuir adsorption. So, in the Langmuir theory of adsorption, it was limited to the formation of monomolecular layer of gas molecules. So, we have studied that in the Langmuir theory, there is only formation of monomolecular layer of gas molecules on a solid surface. And also, it decreases the possibility of multimolecular adsorption. So, due to limitations of this Langmuir adsorption theory, the concept of BET theory is an extension of Langmuir theory. Means this BET theory is an extension of Langmuir theory, and which is the theory for the monomolecular layer adsorption. So, to the multimolecular layer adsorption with following assumptions. Means in the BET theory, the adsorption of gas molecules is from monomolecular layer to multimolecular layer. Because in the Langmuir theory, it was limited only to the formation of monomolecular layer. But BET theory explains the adsorption from monomolecular layer to the multimolecular layer, and it is based on the following assumptions. So what are the different assumptions for the BET theory? So the first assumption is the gas molecules physically adsorb on a solid in layers infinitely. That is the formation of multi-layers. Means the bed theory says that the gas molecules physically adsorb on a solid in layers. Means these gas molecules adsorb on a solid so in such a way that there is formation of infinite layers. Infinite means number of layers, and which we can also call it as a multi-layer formation. And the gas molecules only interact with the adjacent layers. So here is the infinite or multi-layer formation in the BET theory. So what happens? The gas molecules only interact with the adjacent layers, and the Langmuir theory can be applied to each layer. Means when gas molecules adsorb on a solid, so what happens? The multi-layer formation takes place. So these multi-layers, in these multi-layers, the gas molecules only interact with the adjacent layers, and this each layer, these there are, if we consider there are 10 layers, so if in these 10 layers the Langmuir theory is applicable to every that 10 layer, means first layer, second layer, third layer. So each that layer is each that layer is assuming the Langmuir theory adsorptions. Langmuir theory adsorption assumptions. So the enthalpy of adsorption for the first layer is constant. Means the enthalpy of adsorption for the first layer, that is the adsorb of the gas molecule, is a constant and is greater than the second and higher for higher layer. Means for the first layer, enthalpy of adsorption is constant and greater than the second and higher layer. Means the enthalpy of adsorption for the first layer is always greater than second, third or fourth layer, and it is always constant. And the enthalpy of adsorption for the second layer is same as the enthalpy of liquefaction. So the enthalpy of adsorption for second layer, means if we consider for the first layer the enthalpy is constant, for the second layer the enthalpy is same as the enthalpy of liquefaction, means the conversion of gases into liquids. So based on the following assumptions, Brownier, Emmett and Taylor derived the following equation known as a BET equation. Means based on these following assumptions, he derived the equation called as a BET equation, and it is used to determine the monolayer adsorbed gas volume. Means the monolayer adsorbed gas volume, that is Vm. M means monolayer and V means volume. So this BET theory is used to determine the monolayer adsorbed gas volume, and based on the following these assumption, he derived the equation which is known as a BET equation. So what is that BET equation? So BET equation is given by 1 upon V into bracket P0 upon P minus 1 is equal to C minus V, C minus 1 Vm raised to C P upon P0 plus 1 upon Vm C. So what is the meaning of all these terms in the BET equation? So here this V is called as the adsorbed gas quantity. So we can also call it as this is a volume of gas adsorbed, that is a adsorbed gas quantity. What is the P0? P0 is the saturation pressure of the adsorbate. Means P, we know that P is the pressure of adsorbate or pressure of gas. Which adsorbate is here? Adsorbate is a gas. So the saturation pressure of adsorbate is given by P0. And what is the P? P is the equilibrium pressure of the adsorbate. What is the C? This C is called as a BET constant. So this BET constant is given by the expression exponential of E1 minus EL upon RT. So what is this E1? E1 is the heat of adsorption for the first layer, and what is this EL? EL is the heat of liquefaction, or we can also call it as a heat of vaporization. So C is the BET constant and is equal to exponential E1 minus EL upon RT. And the BET equation can be plotted to determine the monolayer adsorbed gas volume, that is a Vm. Vm means the monolayer, M means monolayer, V means the volume, means monolayer gas volume, and also the monolayer gas constant, and also the monolayer gas quantity, and also the BET constant. BET constant, that is a C. Means this BET equation can be plotted to determine the both the values, that is Vm and C. So what is the graph of the BET equation? So we know the equation 1 upon V into bracket P0 upon P minus 1 is equal to C minus 1 divided by Vm C into bracket P upon P0 plus 1 upon Vm into C. So this equation is of the form y is equal to mx plus c. So this is known as a equation of straight line. So y is equal to mx plus c. So this is the equation of straight line having the slope m. M is equal to, so if we plot y, that is 1 upon v into p0 upon p minus 1 versus p upon p0 on the x-axis, the p upon p0 if we plot. So what is the slope of this straight line? Slope is equal to c minus 1 upon vmc. And what is the y-intercept? Y-intercept is equal to 1 upon vm into C. So this equation is of the form y is equal to mx plus c, having the slope is equal to m and y-intercept is equal to c. So if we plot on the y-axis 1 upon v into bracket p0 upon p minus 1. So this is plotted on the y-axis. On the x-axis, if we plot p upon p0, so we got a straight line having the slope. So what is the slope of this straight line? The slope of the straight line, that is m, is equal to c minus 1 divided by pmc. And what is the y-intercept? So y-intercept is equal to 1 upon vmc. So from the slope and intercept value, we can draw the graph of BET equation and calculate the values of Vm, that is the volume of monolayer adsorb, and what is the C? C is the BET constant. So both of these values can be evaluated from the BET equation, and by plotting the graph and by knowing the values of slope and y-intercept, we can calculate the Vm and C. So we can say that thus from the slope and intercept, both the monolayer adsorb gas volume, that is Vm, and BET constant C can be evaluated. And by knowing the value of monolayer gas volume, that is Vm, the surface area of the adsorbent can be easily calculated. Means if we know the monolayer adsorbed gas volume, that is Vm, we can calculate the surface area of adsorbent. So this is the importance of this BET equation, that we, from the volume of monolayer adsorbed gas, we can easily calculate the surface area of adsorbent. So this was all about the BET isotherm. So what is the application of this BET isotherm? So we know that what is the use of this BET theorem, BET equation or isotherm. It is used for the calculating monolayer adsorb area and also the surface area of adsorbent. So we will see the one problem based on the BET theorem. So the problem is given as at a 25 degrees Celsius and 1 atmospheric pressure, means here temperature is given and pressure is given. So the volume of nitrogen gas required to form monolayer on the surface of activated charcoal is 155.5 centimeter cube per gram. Calculate the surface area per gram of activated charcoal if the area of cross section of nitrogen molecule is 0.160 nanometer square. So in this equation, what is given? At 25 degrees Celsius, 1 atmosphere and 1 atmosphere pressure, the volume of nitrogen gas for monolayer formation on the activated charcoal is volume is 155.5 centimeter cube. We have to calculate the surface area per gram of activated charcoal. We know that from the BET equation we can easily calculate the surface area. So here the area of cross section for the nitrogen molecule is given, that is 0.160 nanometer square. So in the solution we can write as the monolayer adsorbed gas volume. Here in the problem the given is monolayer adsorbed gas volume, that is a Vm, and it is the value is 155.5 centimeter cube per gram. So in the dm cube, decimeter cube, how we can convert? So this point is shifted, we can write 0.155 dm cube per gram. So at standard temperature and pressure. So here it is a 25 degrees Celsius and 1 atmospheric pressure, means these are the STP conditions. So at STP conditions, what is the molar volume of gas? We know that at STP conditions, molar volume of gas, that is Vm, is equal to 22.414 dm cube per mole. Therefore, what we can write? The number of molecules contained in the Vm, that is the monolayer volume. How we can calculate? That is 6.022 into 10 raised to 23. This is the Avogadro's number divided by monolayer volume. That is, what is the at STP condition? What is the monolayer volume? 22.414 into what is the monolayer adsorbed gas volume of nitrogen? Here it is 0.155. So from putting all these values, we can calculate the number of molecules in a volume Vm. So number of molecules is equal to 4.177 into 10 raised to 21 per gram. So we can calculate the number of molecules in volume Vm. So we have given here the area of cross section of one molecules, that is 0.160 nanometer square. So we can also write nanometer means 10 raised to 9 minus 9 meter. Therefore, we can write 0.160 into 10 raised to minus 9 raised to square, that is 10 raised to minus 18 meter square. And the area covered by, so what is the area covered by this number of molecules, that is 4.177 into 10 raised to 21 per gram. So area covered by 4.177 into 10 raised to 21 molecules per gram is equal to surface area per gram of activated charcoal. Therefore, how we can calculate the surface area of charcoal? So in the problem we have asked the surface area of activated carbon, that is a charcoal. So by multiplying the number of molecules by the area of cross section, that is area of cross section is 0.160 into 10 raised to minus 18 and the number of molecules is 4.177 into 10 raised to 21. We can calculate the surface area of charcoal and thus the surface area of charcoal is 668.32 meter square per gram. So this is the application of BET equation. So we will revise this problem again. Here we have given the monolayer adsorbed gas volume of nitrogen, that is 155.5 centimeter cube per gram. We have converted into decimeter cube per gram. And we know that here 25 degrees Celsius and 1 atmospheric pressure is given. So at STP condition, volume of monolayer is Vm, that is 22.414 dm cube per mole. So the number of molecules in volume Vm is equal to 6.023 into 10 raised to 23, that is the Avogadro's number, divided by 22.414 into 0.155, that is the monolayer volume. So number of molecules is equal to 4.177 into 10 raised to 21. And here the area of cross section given, that is 0.160 nanometer square. So here it is converted into meter square. So 0.160 into 10 raised to minus 18 meter square. And by multiplying the area of cross section by number of molecules, we can calculate the surface area of charcoal, that is 0.160 into 10 raised to minus 18 into 4.177 into 10 raised to 21. So the surface area of charcoal is 668.32 meter square per gram. So the BET isotherm is very important to determine the Vm, that is volume of monolayer adsorbed, the BET constant C and also the surface area of charcoal. So surface area of adsorbent is easily calculated by using the BET theorem. So this was all about the BET equation. So in the next lecture, we will move towards the last part of our chapter. So we will study the classification of different adsorption isotherms and what is the adsorption isobar. So in the next probably 2 lectures, we will end our physical chemistry syllabus and also our second chapter. So thank you.